In this video, we'll take a look at some of the new advanced triggers that are available in version 5.5 of SignalVu PC. The signal we're looking at is an amplitude shift keyed or ASK signal centered at 2.4 gigahertz. And we can see in the spectrum that we've got two distinct levels here and about 30 dB down here. Those are the levels of our on and off of the ASK signal. You can also see some other spectral anomalies going on with the signal as well. And again, we'll take a look at those with the aid of some of our advanced triggers. So the first thing we'll do is add a time overview display that allows us to look at the time domain nature of the signal by looking at amplitude versus time. And if we grab a little more data over time, we can actually see that we've got a couple of different pulse widths going on here. And I'm just going to grab a little more data here and there. And we can actually see a couple of different pulse widths. Let's stabilize this display by doing a simple RF power trigger here to start with, to trigger on just the leading edge, for example, of this pulse. And we can see that sometimes we're grabbing a narrow pulse here, and sometimes we're grabbing a wider pulse. There are two different pulse widths that are being transmitted here. So if we want to isolate one of those versus the other, we can go into our time qualified trigger capability. Now, for example, if we select shorter than, say I want to trigger on a rising edge above minus 20 dBm, but only if it stays above that level for, say, less than 200 microseconds. If I dial that in here, we can now see that we're triggering on just this narrow pulse, because this pulse is the one that is narrower than 200 microseconds. Now, if we flip it and say I want to trigger only on pulses that are longer than 200 microseconds, now we're triggering on this longer pulse within the group by time qualifying to longer. And we can see we have a couple of other options for triggering on events that are inside or outside of a specified duration. So those are some of the other options that are available to us. Let's take another look at this a little bit further. If we trigger on, say, the falling edge, and set our time qualifier to 500 microseconds, we can see that we're actually have stabilized on the pattern. If we grab a little more data here over time, we can actually see there's a specific data pattern within this RF signal that we're triggering on that longer off time between this pattern, which consists of two narrow pulses, a wide pulse, followed by a narrow, and then two wides, and then that repeats itself. So this time-qualified trigger can be used to help isolate a particular RF events. It can be really handy in radar and electronic warfare systems where you're outputting specific techniques in the time domain. Now let's take a look at some of the other trigger capability that can really enhance the ability to isolate particular events in time. I'm going to turn off the time qualifier. And let's adjust my trigger position here to 20% since we don't need a whole lot of pre-trigger information here. And we'll grab a little bit less time so we can isolate particular events here in time. Again, if we trigger on the rising edge, again, now we're triggering right here, as you can see, on the rising edge of the pulse. We could also see that the spectrum now has got a little bit of an interesting shape to it, because now we're only measuring the spectrum at that location in time. See the little red bar right here. So the rising edge has got an interesting spectrum to it compared to when we were free running. Most of the spectrum was sitting here. So it's clear that something is going on with the spectrum coincident with the rising edge. Now, a nice way to look at the overall spectrum that's happening in real time is to add the DPX display. Now, the DPX display is showing us now that there's a lot of spectral energy occurring on either side of the main carrier of this ASK signal. A little bit of splatter on the low end and splatter on the high end. So we can actually use some of the advanced frequency domain triggers to trigger on those spectral splatters to see where they're occurring in the time domain. So the first trigger mode that we'll take a look at is called the frequency mask trigger. The frequency mask trigger allows us to define a frequency mask by right-clicking and adding new points, or using the buttons up here to add points, and clicking and dragging and move those points around. So if we, for example, move this point down to here and say trigger when we go from a false to true transition, that's this selection right here. So when the instantaneous spectrum of the signal crosses into that mask boundary, that's what we want to trigger on. So with that mask defined, we can actually see that that's occurring coincident with the rising edge. So the rising edge of each of these pulses that are happening is actually resulting in this spectral splatter. Let's see what's going on with the spectral splatter at the far end. We'll go back to our mask editor. I'm going to pull this point up out of the way here, and maybe I'll move this point here, add a new one, and drag that point down into this lower edge here. Hit OK. And we can see that that is coincident now with the falling edge. So the falling edge has got some splatter associated with essentially increasing the frequency a little bit. So another way to look at this, we'll shorten up what we're looking at here and just kind of focus on our triggered area. And let's add a spectrogram display. And with that spectrogram display, I'm going to zoom in on that here a little bit. And I'll just stop it here for the moment. So this is showing me essentially spectrums over time. We can see our trigger location right here. If I right click and add a marker, we can take a look at what the spectrum is doing at different locations in time. You can see during the on time of the pulse, I can see where the spectrum is occurring. And as the pulse actually turns off, we can actually see that spectral splatter, and it actually goes a bit to the low frequency side and then to the high frequency side. Take a look at the red spectrum trace in the lower right as I move the marker back and forth. Now if we reset our mask to look at the splatter on the other side, hit done and run again. And again, we can, now that we're triggering on that, we can move our marker through here and actually see the spectral splatter as the amplitude starts coming up. It comes up with the frequency on the low end, and then eventually comes up, wiggles around a little bit, and finally settles out at the center frequency again. So the frequency mask trigger can be proved to be very useful to isolate transient spectral anomalies in your RF signal, so you can look and see what's going on in the time domain, understand where those anomalies are occurring. Now there's one more frequency domain trigger that we can use as well, and this is called the DPX density trigger. And this takes advantage of the fact that the DPX display is showing you effectively spectral density, or how often various portions of the spectrum are occupied over time through, and visually here we're seeing that in our color display. But we can actually use a trigger region, adjust its size, and also adjust a threshold. So if we leave the threshold at 0, if I take this spectral region and I simply move it over a portion of the spectrum that exceeds 0%, now I'm triggering on that portion. So again, we know that this portion of the spectrum is occurring during the rising edge, and I can see that over here. If I move the spectral density region down to this lower edge here, we can see that's coincident now with falling edge. The spectral density region can be really handy for triggering on signals inside of other signals, because you can set the decision threshold to a spectral density something other than 0%. So being able to trigger on signals under other signals can be really handy. And the final handy thing with DPX density trigger is we make it really easy to implement. You don't have to go down here to the trigger selection box and turn it on. You can simply point to a region on the DPX display. Let's say right here where I've got my mouse. And if I right click, I can say trigger on this. And what trigger on this does is it switches you from free run to triggered if you were in free run mode, switches the trigger source to RF input, the trigger type to DPX density, puts a default size box on that area, takes a look at the spectral density in that box and reduces it by about 10 or 15%, and sets that threshold available for you. So you're now, by right clicking and saying trigger on this in this area, I'm triggering on this particular event now. If I do the same thing down here, right click, trigger on this, it readjusts to trigger on that portion of the signal. So it's a shortcut way of enabling this DPX density trigger, and then from here, if you want to, you can go and resize the box, move it around, or change the threshold as needed. But the right-click trigger on this feature makes it very easy to implement this very advanced triggering capability. So I hope you've seen in this short video that the advanced triggers added with version 5.5 of SignalVu PC, which include time-qualified triggers for things like edge triggers, as well as frequency mask triggering and DPX density triggering, can greatly enhance your ability to isolate particular RF anomalies and RF events into your acquisition so you can further analyze them and debug your system.